All right. It's guys. Okay, so welcome to today's class, which is a very important one. Sorry, today was supposed to be a quiz and end-on practice session, but based on the um all big projects you are on, so I decided to give you time to work on the project because it's a very big one. Then while we still study. So today we'll do more of talking, explanation, and trying to get our head wrapped a lot of stuff. And for that's important. Okay, let me zoom in. I made these documents which I will share after the class to help with the explanation. So I will do a lot of talking and then I will refer to this document timely. But before I get to explain, before I get to talk, before I get to go ahead, let's first answer this. What is machine learning? Right. So machine learning is a subfield of artificial intelligence, which is AI, that focus on enabling computer system to learn from data. Take note of that data. We have to talk about it more. Let me take note of that data. Okay. All right, to learn from data without being explicitly programmed. Another word to take note of, and I'll take that part again. Machine learning is a subfield of artificial intelligence. Okay, so let's say it's under the umbrella of artificial intelligence that focuses on enabling computer system to learn from data. Another keyword we'll talk about today, learn. Learn from what? From data, okay? Pick that without being explicitly programmed, without always telling it what to do at every time. Okay. So instead of relying on predefined rules, machine learning algorithms identify patterns, make predictions, and improve their performance over time as they are exposed to more data. More data, I will talk about this. Now, this ability to learn from data makes machine learning a powerful tool for solving a wide range of problems in various domains. Okay, so there are a lot of things here in this definition, which I will take my time to break down. Okay, there are a lot of things here in this definition, which I'll take my time to break down. Now, you might want to think, and please, as I'm trying to explain, try to think, try to imagine things. That way, it will help you understand. Now, how will that come in? Try to relate what I'm saying to real life scenarios, to what we are having presently. And that will help me and it will help you understand better. So, from this definition that has so many things inside, I want to break them down. Now, picture machine learning, and to think of it, it powers some of the most important technologies we used. You could see the what came out recently, the self-driving cars. Okay, so this comes from translation of apps to autonomous vehicles. All right. Now, these apps, some of them helps you to automate tasks. Some of them helps you to work fast. So this is achieved from the knowledge of machine learning. And just to note, machine learning solve as in it offers a new way to solve problems, right? It answers complex questions and creates new content. Talking of contents, this comes to content creators, which we have a lot of AI tools that has helped them in that field. And just to know that machine learning, okay, it can predict the weather, it estimates travel times, it recommends songs, okay, it's just as an inspiration to songs writers. It also completes messages or sentences. You could see that when I enable it on my words Google Colab, as I'm writing my code, it will just help me to auto complete. That way, it helps me self-typing time. It summarizes articles. Maybe you have a 10 paper, or you have, how should I say, a large article, and you don't have the time to sit and read all of that. It helps you summarize articles and generates never seen before images. It also helps in that. And when it comes to generate, yeah, I need to talk more on that when we get to generative AI. Okay. Now, just to note, as I'm in this slide, I might not see what is going on there. So if at any point you lost me, see I'm sharing my screen full, can just unmute and let me know you lost me. Now, for the course of this, there are some things that we need to talk more about. And I may want to give a very practical definition of machine learning, but in basic terms, because you are just starting. So I could say that machine learning is the process of training, take note of this, training a pieces of software. What is this software? We get to know. Training a pieces of software. We could also call this software model. You get to talk about it as I'm writing now. So it's a process of training a piece of software, right, called model, to make useful prediction, useful predictions, or generate content. And this content I made mention, what type of content can it generate? You can see your ChatGPT, which generates text. You can see your which one generates your I think Flux, yeah, Flux AI, which generates images. You could have the one that the Sono AI, which generates audios like sound, and I think the VO, which generates video. And how does it do that? From data. And what is this data from? Once you prompt it, and it's learned from previous data, it's learned from the one they read and produce this. Then okay, I have learning here, so we're going to talk about it. Now, for example, I'll get to this slide. I'm just trying to explain a lot of things so that when I get to lighting in this slide, it will help you better. Now, for example, suppose we wanted to create a app, all right? Just picture it, as I said, as I'm explaining, just try to relate it to real life. Imagine how is weather predicted? How do they predict when it's going to rain? Okay, how do they predict when it's going to be sunny and all of that? Now let's say we have a weather app that predicts rainfall, and we could use either before the how should I say, the adventure of this AI, we had the traditional one. Say, remember back then in secondary school where we could use the physics approach. Okay, so we can call that the traditional approach. Note of that, traditional approach. Is that its approach? Okay, so it's fine. And using this traditional approach, you create a physics-based representation of, just try to picture your mind back then in school, I don't know if you're science, of the representation of Earth's like atmosphere. And how does it done? It's done by computing the mass. Do I still remember that time? I think it's done by computing the mass amount, something like that, amount of rainfall, or how could I say, fluid, either way, and which is incredibly difficult. But yeah, machine learning models helps makes our life easy. Okay, so if let's say we pass a machine learning model, and this has to come with enormous amounts of weather data, which has been taken for quite a long period of time. Okay, so what the machine learning models will do is that it will learn. I'm using this word enough, so you're saying I'll talk more on this. It will learn from the past years of rainfall. Okay, maybe some up to 100 to 200 years of rainfall data they pack. Okay, in the months of January, the amount of rainfall like that, January, February, March, and for a very long period of time. Now, when all this data is being collected and compiled and now as it, okay, this is where we trained the model and it learns from that to what to bring prediction. So it's this you could call either prediction or estimation because yeah, okay, let's say for the past 50 years, we have up to 50 to 60% of rainfall in the month of July, just like currently what we have now. So it is expected that next year, July, we also have a closer amount or a closer percentage of rainfall we had previously. So that is how it learns. Okay, now we could say that a model is a mathematical relationship derived from data, okay. How is this done? Now this model are the features. Let me add that. We still need to talk about that. Features. Okay, we have features. Is that features? It's supposed to be F and E before A. Features. I'll talk about features. I'll talk about label. Label is the results. So let me write it down. I not forget. Talk about features, label, and we have example. Okay, example. So let's go. Now we have types of machine learning, which some of this falls under. We have types of machine learnings. We have a lot types of machine learning. And before I get to leave the definition, let me see if there's something that is there any word that I've not, yeah, it's okay, learn predictions. I've talked about that performance. Okay, before I even get to hierarchy, let's get to types of model training. Okay, we'll talk about that. Okay, types of machine learning before we get to, yeah. All right, so let's stay. Now for that, let me have it down here. We have supervised, supervised learning. We have, for this, let me give space. Okay. We have unsupervised learning. We have reinforced reinforcement learning, and we have generative, where most of the things happen, generative AI. Okay, so let's pick them one by one. Supervised learning. Now bring your mind back and try to think, what is this supervised learning? Before I even get to the definition, right? Let me set a real life scenario or example of supervised learning. Now think of supervised learning as a school, maybe a student who is trying to prepare for a terminal examination. Take notes and follow me now. Think of it as a student who is trying to prepare for a terminal examination by reading past questions that also has answers. Okay, let's say I want to take JAM now. Okay, how do I prepare for it? Under supervised learning, I'm explaining now. I'll say, okay, I'll prepare, I use past JAM questions, okay, and prepare for them. And these JAM questions as answers, all right? I will now try for numbers of years try to study each of the questions with the answers. Now, this will help me prepare for the exams because, yeah, still same curriculum, right? Even if the answers change, it will ask some relationship and I can make predictions from that. Okay, so what I'm doing is I'm learning. Okay, so this is where this learning comes from now. All All right, so I'm trying to learn, okay, what the model to do, what to prepare, and what I'm learning as label here is what's the result. So the what I'm learning is the data, okay. The data comes with what, with results. So I'm learning it, okay, to make prediction. Okay, let's say in these exams, still we know in mathematics we have algebras, we have sets and all of that. Yeah, if set question comes, maybe it's the numbers that will change, but of course we know we use addition, multiplications and all of that. So if I study well, it is believed that I've learned a lot, I've been trained, okay, I've learned from the data, and I'm using the materials to train myself, okay. Of course there are labels which are answers, so it will help me make prediction. Okay, so now let's get to the definition of unsupervised. Okay, in supervised learning, the algorithm is trained on a labeled data set. What is this data set? Okay, large data. All right, so collected data is what data set, meaning that each data point is associated with a known, this known now, look at a known output or target value. So this known output or target value is me using examination past questions to learn that has the answer. Okay, so it has output, it has target value. So this target value in machine learning, we call it label. Okay, so the goal of this algorithm is to learn a mapping function that can accurately predict the output of new or unseen data points. So what this means that even if they bring a new question to me, it will relate to what I've been trained, to the data that I've been learned, to the data that I've been training upon. So it will help me predict output for new or unseen data points. Okay, so now under this supervised learning, we have what is called regression and classification. Under say supervised learning, we have one regression. Ah, Jesus, me, I'm spelling this. I think it's double S. Regression and classification. Classification. Yeah, I think that is it. Okay, now, so we pick one by one. Under regression, a regression model predicts numerical, take note of that, numerical value. All right, so I'm writing it down so I don't forget. Regression model predicts numerical value. I made mention of rain and weather. I'll still go back to it. So just take your mind there and wait for me. So it predicts numerical value. For example, let me still reference the weather. All right. So for example, in a weather model that predicts the amount of rainfall. So what is going to be the result in inches or millimeters is a regression model. That is one of it. So how many percentage of rainfall did we have in the month of January? How many percentage, what is those is numerical value. It takes note of that. So let me pick out another scenario. Another scenario is maybe you want to go get a house from somewhere, you want to relocate, but to put the house price in condition, there are some possible data inputs. Okay, and I'll be using data much now, which could be where is this house, this new house, where is it located? Okay, so these are the factors that will determine the price of the house. The house, where is it located? Okay, how many numbers of bedroom, how many numbers of bathroom, something like that. Where it's located, is this accessible? So now this data input now from there, okay, if it's not really inside, maybe interior part village, that means we expect that the price will be, how should I say, high. That is where the numerical value comes in. Okay. And now maybe you want to book a boat, what type of, I'm trying to picture it to real life. That is why I'm saying I'm trying to explain, also try to take your mind, um like try to relate your mind to real life so that it will help you understand. So let's say you want to pick a ride now, maybe a boat. You first, oh God, if I should get a Camry, the price, have you seen this? These are input data now that you're putting into consideration. If I get a Camry, I mean the price will be low. But if I get a Prado boat, you get it now. That means the price will be high. Okay, so these are some factors that helps determines the words or helps predict the value, but in numerical, how should I say it, values. Okay, so that is that for regression. Please follow. I made mention that you do a lot of always call my attention to it because there are a lot on my head now. Might miss some. Okay, now for classification. Okay, now let me try to explain it again before I go back to the definitions we have on this slide. Now, classification models predict the likelihood. Please take note that something.
Hello, Uber.
Out. Classification models output a value that states
Hello,
whether or
Duak. We
not
lost
something
you
belongs to. Oh my goodness, from where?
from the beginning of classification.
Okay, that means it's not far. It's not far. I just started. I just started. I just started. Now, I'm saying that classification model here, which is under supervised learning. So classification model predicts the likelihood that something belongs to a category. Okay, but let me take your mind back. Unlike regression model, okay, whose output is number, like numerical value. Classification models has put a value that states what whether or not something's happen. I'm still going to explain that. Now, this picture is a scenario. Now, this category could be example. Let me say, okay, so you could take whether it rains or it did not rain. Okay, something happened or something did not happen. So that is what's the category that I made. All right. So for example, classification model are used to predict email spam. So what does this does is that were you spammed or you were not spammed? In this video, is it human? Is it real? Or is AI generated? So those are the categories, right? Did this happen or this happen? Okay. Now, this classification model are divided into two groups. Remember category groups, and one of it is binary, and another is multi multi class. Right. Now, for the binary classification, models output a value from a class that contains only two values. Take note of that. Now, what do I mean? For example, a model that outputs, again, I still want to use rain or weather. So, for example, a model that outputs, did it rain or it did not rain? Okay, this, how do you understand that? Did it rain or it did not rain? So let me go back to the definition of this binary to help you relate what I've just said. I mentioned that binary classification model outputs a value from a class that contains two value. So its result is two. So it's either it rains or it not rains, and it stops there. But for the multi-class, just as the name implies, for the multi-class classification, what does it do? It output a value from a class that contains what more than two value. Let me still use rain. Now, this one now that is bringing two, did it rain or it did not rain? It did not picture as, oh, yeah, it wasn't raining or it was drizzling. It comes with slits. I don't know, the slate now is this rain that comes with some ice droplets, or it was just raining while the sun was still on. It did not go for that to explain. But for the multi-class, okay, so it tells you what type of rain. Is it that the rain was heavy? Is it that it was which one? Snow or slates? This one that rains with some ice droplets, or it was just this lane. Okay, so that is it for supervised learning. Let's check the definition. Okay, check now. Under that we have this now. This will be my explanation. Let's check the wordings. Now, the goal is to predict a category. Okay, mention this, a category output, such as classifying an email as a spammed or not spammed. I mentioned this, or identifying a species of flower based on its characteristics. Okay, so common classifications our algorithm includes logistics. These are some things we look at: logistic regression, support vector machines, which are SVMS, and decision trees. Now, if you did see something from here, it tells you that this was me telling the types or groups of classification, the binary and the multi-class. So you could say that the first one is telling you that it's classified if as like it's classified an email as spammed or not spam. And another one you could see or identify the species of flower based on the characteristics. So this should tell you that this one falls under what multi-class. I don't know if you are following up and you did not lost me yet. All right. So now for the regression, which I also talked about, the goal is to predict a continuous output, such as predicting the price of a house based in a size or location. I mentioned this, or forecasting the temperature for the day. Now, common regression algorithm includes the linear regression, which we talked about as we proceed, polynomial regression, and decision tree. So classification, this what supervised learning tasks to choose. Okay, so now how do you choose that? This you are to choose either classification or regression while working on your models and relating this now because you'll be given a project to work on. So you now decide to choose between these two based on your label. And what did I say? Label is output, right? Now, based on your output that you expect to have, do you expect to have a numerical value as your output? Or do you expect to have to have a particularized value as your output? So this is where you get to know the choice of what you do. Right. So the project will be left open, and what that entails is that it allows you to think and apply some real life scenarios to your project. Okay, so example training okay. So this is example of a project which you may likely do, training a model to predict whether a customer will click on advertisements based on the demographic information and browsing history in a supervised learning task. So now, based on this demographic information, where they are, could be people from this side. Okay, they often click advertisement. They're often curious. People from this side, those ones they will just scroll and pass. So this one will help you, and they are telling you that it is what classification based on it represents how many type, like two values as what result, which will they click the advertisement or they will not click. So this is telling you that it is what classification. Okay. um Data training quality, we come back to this. Wait, please just remind me this. I want to bring this somewhere. Are we together? Okay, so you just come attention to this later on. Okay, now let me even test your understanding so far. Because you're doing a lot of talking. So you just sit down and be listening to my talking. Let me check your understanding. Now listen to this question I'm going to throw out to you. Now, if you want to use a machine learning model to predict energy usage for commercial building, what type of model would you use? Is it classification or regression?
Regression.
Are you with me? Okay, so why
Regression.
do you pick regression?
You said regression
Yes,
is
I
you
said
said
yeah,
it's
it's
used for
regression.
numerical value to predict numerical
Okay,
value, like a
beautiful,
particular
beautiful. Okay, so
answer.
it's regression. Yeah. So if you want to use ML model to predict energy usage, you can come back slide. All right. Up you did not last me. All right. Am I still audible? Can you hear me?
Loud and clear.
All right. So let's go. So we've talked supervised learning. Let's talk about unsupervised. Now, from your knowledge of give me the definition,
You have
just explain. What do you say?
I said we kind of lost you a minute ago. Are you about
All right.
begin the unsupervised explanation?
Okay. So I'm saying, based on all that I've said concerning supervised learning, can you try and relate what's a little what's unsupervised learning should be? Okay, I was telling you to think or to imagine things. So if you were thinking while I was talking about supervised learning, you should be able to give me something. Okay, for time's sake, for the sake of time, unsupervised learning, before I even get to it, you should know that if supervised learning could be that, okay, a model is given a data and an output is given, output is labeled, take notes. Very soon I will not be using output again, I'll be using label. So not when I use label, you like what is label. So label is kind of results, the output. So if I made mention that in supervised learning, you have the data, you have the features of everything, and you still have the result, which is label. So you should know that in unsupervised learning, the data are given, but no no results, which is the label. Okay. All right, so let me try and explain this before I even come to the definition. So unsupervised learning models make prediction by being given data. And what are these data that does not contain any correct answers? No label in it. Let me be using label. Now, an unsupervised learning model is to do what? To identify meaningful patterns or meaningful patterns amongst data. A pattern is that you give it data, so it is left for it to learn from this data, identify patterns, and what bring out possible results. So, in other words, I could say that the model has no hint, nothing, no glue at all, no hint on how they and how to categorize each piece of data. So instead, what does it do? It must infer on its own. So this comes with what I will talk about large data and diversity. Large data, large data. That just comes to my head now. Oh, he's not even here. Sorry. Where is unsupervised? Yeah, we are done with supervised now. We're unsupervised. So this could come to where we have large data and what diversity. By diversity, I means okay, I'll still come to that. It means diversity, diversity. Okay. Now let's say I should have, now under this we have something called clustering that we talk about also. That just come into my mind. Let me get it down so I don't forget. And let me quickly refer to that. Let's say a commonly used unsupervised training model employs a technique, okay, called clustering that I'm using now. And the models find data, okay, from this. Now let's get to the wording so this will help. That's clustering, okay, okay. So this will help. Right, in unsupervised learning, the algorithm is trained on unlabeled data sets. Of course, you know what label is by now, meaning that the data points do not have oh, you've not lost me. Okay, basically. Where did I stop? Meaning that the data points do not have associated output value. Let me take that again. In unsupervised learning, the algorithm is trained on an unlabeled data sets, meaning that the data points do not have associated output value. Labeled data sets, output value. That should sound something to you now. So the the goal of the algorithm is to discover hidden patterns by itself. Okay, by itself. Okay, this now just remind me of something we talk about. Let me write it down. What is called loss. Okay, talk about that. Okay, so the goal is of the algorithm is to discover hidden pattern, right, or structure, hidden patterns, structures, or relationships within the data. Now, unsupervised learning tasks includes what it does. Okay, all right. So clustering that I was trying to talk about. The goal is to group similar data points, okay, together into a cluster. And by cluster, so many large things, clusters, let's say could be like points. I don't know. Let's say you're trying to plot a graph and you have a lot of points that clusters everywhere. Okay, so just picture that. I don't know which other real life scenario I could attach to this, but just picture it based on that aspect. Okay, the goal is to group similar data points together into clusters. For example, includes key means. We talk about this maybe next week. Key means clustering and hierarchical clustering. Let me not go for that, not to confuse you. And another is dimensionality reduction. Okay, what is this? The goal is to reduce the number of variables. Please listen, as I'm going like a bit advanced, this is from the basic to here, it might get confusing. But if you pay attention, and then again, the most important thing, and try to think and imagine as I'm explaining to help you understand. So the goal is to reduce the number of variables in a data set. What did I say? A data set is collections of data, right? While preserving its essential information. So this can be useful for visualizing high-dimensional data or improving the performance of other machine learning. So all this too much English. What it means is that it helps to visualize high-dimension data that has a data set, that has so many data sets, right? And it's trying on its own to visualize. It's struggling on its own. Remember, there's no label. It's on label data set. Okay, there's no output, so it is left for it, all right, his duty to try and get a result out of this. And associating rule meaning. This goal is to discover relationship between different items in the dataset. For example, identifying which products are frequently purchased together in a supermarket. A common algorithm is for association rule, mining, blah, blah, blah. Okay, so now what this means is that, how should I put it? Let's say you have large numbers of data. Now, let me still use rainfall now. Okay, let me still use rainfall. You have now, yeah, for that I made mention. A lot of things still come into my mind. So let me talk about this before I even get this large data and library system. And this large data now is maybe hundreds years of data. And for this large data, although we still talk about it in the call, but let me still say a little about it, is maybe you have large examples, large inputs, okay? And diversity is for how many numbers of months, okay? And let me see use rainfall now. Let's say a large data has been collected for 100 years, all right? And with diverse months, and this diverse months is that 100 years it takes from January to December. But what happens to a situation whereby 100 years, now take note of this, 100 years of same data is collected, but maybe only for the month of July, but it is large only for the month of July. Do you think that that data can out predict rainfall in the month of January or in August? No. Now for the diversity now, if it still gets data from January to December and it's only for 2 years, do you think it has enough data to predict weather? No. So what do? We need the combination of this. We need large data, maybe for many years, and we also need it for many months, not for a specified month. I don't know if that makes sense, but it should. Now for this loss, loss measures is a value that predicts between this loss is the difference between between predictive value and the actual value. We still talk about this, but let me just throw more light. This loss is the difference between the predictive value and the actual value. So now let's say the actual value is, let's say 0.5, and the predictive value could fall under 2 or under 1. So it's for it to get this and check the difference, then still train again. And there are some things we developers could do on ourselves to help get to this points. I'm going outside this, but let me see. So to help get to this point, there are some features you need to. This is where it comes to the level of feature relationship. Okay. So what this means is that there's some features here now. Don't forget features. Features here are like examples. Okay. There are some features that are not related at all. At all. Like let's say you want to get a house, and does the color of the house makes the house expensive? Mind you, the model you are training was to see how expensive the house could be, and someone just bring it the house paint or the house color. Does that sound anything? Nothing at all. It's also, if it's painted blue or it's painted pink, it's still maybe your color preference, but it's not really add to the output. I don't know if that makes sense. Let me leave it. I'll talk on them respectively, but I need to just throw more light on that. Okay, are we still together? All right.
Yes.
Where are we? Yeah. Okay, not here. Which other word? Reinforcements. Okay, now for this reinforcements, not really used, but let me just say a little. For this reinforcement model now, it's a model that it's predicted, or how should I say, it makes prediction by getting reward based on reward or penalty, because either call it reward or penalty based on actions performed within an environment. I'll say come to that. So you could say a reinforcement learning system gets policies that define best strategy to get the most reward. Maybe you could link it to what I said here. Let's check the definition. Okay. And under where grouping, clustering, if we talk about that. For the reinforcement learning, in reinforcement learning, an agent learns to take decision. Okay, I mentioned this in an environment to maximize a reward or penalty. Take note of this. The agent interacts with the environment, take decisions, and receive feedbacks in the form of rewards or penalty. Now, the goal of the agent is to learn a policy that maps states to actions. Okay, states to actions, what happens and the actions in a way that maximize cumulative reward over a period of time. Do we have something here? Okay, we're done with this, but still take note of the diagram up. I still have issues with that. supervised learning, unsupervised learning, clustering. We talked about this, dimensionality, little but not much, algorithm, specific method to each task. Okay. Okay, reinforcement learning cycle. Let's see. First, it learns policy. The agent update is it starts here. The agent, first of all, interacts with the environment. Okay, so the agents take actions within environments. What is happening? Is it conducive, and all of that is based on what. Keep in mind what rewards or penalty. This reward or penalties comes with actions. So when a state is given, you have to interact with it to get what is the action. So it maps actions to what. All right, so receive feedback after it has interacted with its environment, it takes feedback. The agent receive rewards or penalty. So what is this? Is it good, bad? So from this now, it learns. The agent updates its decision-making strategy based on the feedback they've gotten. The feedback will help it make some strategic decision and maximize cumulative. The agent aims to achieve the highest reward over time. So if this cycle still continues for a very long time, it will get to the highest reward over time because it is learning. There's no how you learn one thing for over a period of time and you not get used to it, you not master it. So even if when you're waking up from sleep, you just give it because it's what you've been learning. Okay, so reinforcement learning is often used in applications such as robotics, game playing, control system. Common reinforcement learning algorithm includes the key learning, deep learning. So you could see this now in robotics is that they pass so much data to it and it learns over a period of time so that it can now work on its own. It can now take actions. So it's learn from this cycle now. So try from what I'm saying, map your brain to this cycle, come back again to where it's gets to how should I put it, to maximum usage. Okay. So game planning, you even have, I think there are games now that you can play with the computer, you and the computer. So how do you think the computer gets to learn the game and it plays along? All right, so now key concepts, label, training, testing. This is where we get to this now, label and all of that. But before then, there's what is called generative AI. I did not include here why. Why? Are you sure? Okay, so I think that is an oversight from my end, but let me try to talk about it. I just remember, did I have it on my notes? Generative, yeah. Oh, sorry, I did not include it on the documents. Okay, so for a generative AI, it's very important. This is what we use on a daily. This is what we use on a daily. Am I still together? All right. So let me try to explain this. So a generative AI is, how should I put it, is a class of model that grades content from users' input. So that is why I said I will use it on a daily. So as I'm trying to tell you, picture your ChatGPT, picture Gemini, picture your Google Microsoft FX, which generates images, picture Leonard AI, which generates images, picture Yosuna AI, which generates audio. So just try and imagine things as I'm explaining so that it makes sense to you. So generative AI is a class of model that grades content from users' input. That is prompts. I think I have something like that here. Prompts. I did not think. Okay, prompts. Now these are how the input can be prompts, and this input now is data. Not data, but how should I relate it now? They're trying to prompt it to bring words. And it has even been optimized that it bring a tailor-made output or label. Okay, so for example, generative AI creates unique images, how should I say, content, which like music compositions. it can summarize articles, it can explain or how a task is done. Maybe if you go to ChatGPT now, you don't know how to cook rice, but like step by step, explain how to cook jollof rice. It will do that for you. It can even edit words. We have AI tools that even edit pictures, edit videos, and do more things. So in a wide sense, AI, generative AI can take a variety of inputs based on your prompts and create varieties of outputs. Okay, so like text, we have text, images, audios. Just try to think what you've been using. We've been using this on a daily, all right? So we could say text to text, which you give, there's some AI that you put in text and it will give you label text. Remember, I'm not using label, if you know what label is. You could give it text and it gives you image, your Google FX, your Learner AI, and the rest. You could give text and it gives you video. Good, there are text to speech, there are text to audio. A lot of them you've been using it on a daily, so I don't have to talk much about that. So now, in a very high level, let's even picture this. How does this generative AI work? So it is not you using it. If you use it, just try to think, how does it work? What is the wide level about it? All right. So at a very high level, generative models learn pattern in data, all right, with a goal to produce new but what similar data. So generative models are like, for example, now let me picture, yeah, something just gets to my mind. Let me picture a very life scenario. Let's say if you're watching your comedians now I want to picture them now to generative. What they do is that you could have your comedians who learns to imitate others by observing their 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 objects, people they are targeting, people they are using to make jokes. So what do I do? They will observe how those people behave, the style they talk, the style they speak, so that when they come to stage rather, they will try to mimic those people. They will try to imitate them. So that is it. That is a very one real life scenario. Or you could say an artist who learned to paint a particular style by studying lots of painting style, okay, in that field. Another real life scenario I could say to you is yeah, let's say you have a cover band, okay. So for them to perform like a music group, they have to learn the sound of those specific music group that they want to do. So how do they do this? By listening to a lot of music by that musical group. So you can add others and listen other examples to yourself. Okay, is there any question? And you last time we okay, so let's check the wordings. Okay, I did not have this thing. I did not have wordings for generative AI. Are you lost somewhere? Do you have question? Or you are we even together? Hope you are hearing me. Okay, you are good. All right, so let's get to this. But before we get to these wordings, let me explain first. And again, as I'm explaining, still try to think. All right. Okay, so let's go one by one. Let's go. First is data, learn, training. Okay, so first let's go to data, right? And for this now falls under what? Yeah, so that you know. This falls under supervised. Supervised. Maybe spelling this. There's a supervised learning. Okay, I think that is it. So now these are some of the foundational supervised learning concepts, and we look at it one by one. Okay, so I've been using data a lot. I've been using training, learning, model, predictions, features, label, examples. So you could ask yourself, what are they, and all of that. Good thing I've talked about. Okay, data. So before we get to the wordings, let's picture data, right? Let's try to explain it. So you could say that data is the driving force of machine learning. Why? Yes, because without this data, where would it learn from? So it is the core, right? It is the core or driving force of machine learning. And again, data comes in the form of words, numbers, stores in table, or as values. It even comes in a wave form. Okay, people do in a wave form, which could be captured as images and audio files. Okay, so don't limit your thinking. When I tell you to think, don't limit your thinking. Don't limit your imagination. Let it be wide. The data could come in a lot of forms. Could come in text, in values, in wave forms. So we store related data in data sets. I made mention of data sets now. Okay, which could be collections of data. Okay, for example, we could have a data set of doc images, doc images. How do I spell image again? Doc, yeah, that's doc images. You could have the data of um housing price. Talk about that and others. Yeah, talk about weather. So you could also have a data set of weather informations like that and others. So now, what is a data set and what are they made of? Now, these are where things get more interesting and somehow advanced, not advanced, but it has a lot of things inside, so pay attention. So we could say that data sets are made of individual examples. Where is examples? Okay, I'll talk about it. So now I'm explaining data sets now. So from that definition, it has so many things inside. So listen. So data sets, I do not have it. Data sets. Is that it? Yeah. So data sets are made up of individual examples that contain features and labels. It's made up of individual examples that contains features and labels. Now let me break it down. You could think of an example now as a analogous or single row of spreadsheets. I don't know if you've worked with spreadsheet before, so I'm trying to relate it to real life. So those are examples. Spreadsheets, you have a lot of things inside, right? And you could also thought of features as the value. So these features now are the values that supervised models use to predict labels. So these say their contents, if I should call it that way, their input values. Okay. Just try and think. I would also try my best to explain. Okay, that helps to predict what labels. So you could see this label as the answer or the result if you're talking about it. Or somehow the value the models want to predict. So it could be in numerical form, it could be in group, we talked about it. So now for this, you can picture it as example of, let's say, let me still use weather. Let's say a weather model that predicts rainfall. And the features, I'm talking about features now, and the features could be, what are the features of rainfall? Yeah, you could check the temperature. How is the temperature? Even we humans, we do predict if it will rain. Yes, I do. If you see how the weather is cloudy now, you could see the temperature go like, it might rain today. So now let's say these features now includes the temperature, the humidity, maybe say wind direction, or how could I say the atmospheric pressure, a lot of features. So these features could be determining factors, if I should call it that way. So they are just examples, right? And afterwards we have levels. So from all this, it is the weather is cold, it is humid, the wind, everything. So that could help even us human to predict, all right? But in contrast, let me take your mind to that. Unlabeled data, okay, or should I say does not have this label. There are ones that you give features, and from the features it will decide, just like I'm telling you now. And there are some data that comes with label, which are the results, just like when I took your mind to studying maybe jam past questions to prepare for jam. Okay, and now let me even get your mind to where this now, which could be the, you can call it the characteristics of a data set. Is a data set large, diverse, and all of that? So a data set is characterized by its size. This way I could call it large data now. That just enters my its size. Okay. What's happening? By its size, right? And what diversity. So size here now indicates numbers of examples. How many are there? Do we have enough of them to help you predict? All right. Diversity indicates the range those examples cover. Just to note that good data sets are both large for the size now and diverse. So data sets can be large and diverse. One, it can be large but not diverse. Two, okay, or it can be small but was highly diverse. I may mention this when I was trying to throw more light on this. So in other words, a large data set, like I made mention, doesn't guarantee sufficient diversity. And a data set that is highly diverse doesn't guarantee what sufficient examples. So if it is large and small, it doesn't still help. If it is highly diverse and small, it doesn't still help. So what makes a good data set is that it must have a large data, like I mentioned, 100 years of data with diverse. Okay, let's still use rainfall now. With maybe it runs from January to December, but let's look that is large data now. For each of the year till it gets to the 100 years, it starts from January to December. But let's look at when it's this diverse. Let's say from January to December, but just for 2 years, it does not still help. So the data must be large and it must be highly diverse. Okay. Now, people are just too quiet. Let me throw one question at you now. What attributes of this data set would be ideal or used for machine learning? Is it small size and large diversity? Is it large size and low diversity? Or is it large size and highly diverse? Which one?
Large and highly diverse.
Okay, beautiful. All right. And just to add for this again, let me pick one something. Consider that a data set can also be characterized by the numbers of its features. For example, let me see use the way that all of us we are familiar with that. A weather data set might contains hundreds of features, okay, maybe ranging from what the cloud coverage and all of that. But other data sets might contain only 3 to 4 features, okay, like humidity or atmosphere. So if the cloud is cloudy, but the temperature shines, it does not predict, you can't even tell if it's going to rain or not. But if you see other features now, the clouds is cloudy, there's so much wind, and the weather is with ice, it's just too cold. You can pick something from there. So it can help you make a very good prediction if it's going to rain or not. Okay, so I think I've talked too much on what's data sets now. Let's get to model. Where is it? Model. And what are these model? In supervised learning, okay, let's check the definition now. Did I talk about data here? I was rushing, so I did not add a lot of data. But then with my explanation now, you know what data is and a data set is. You don't still need this. Okay, so let's get to model. So do I have model there? Oh God. Okay, I'll try and do my best to explain. You still get it. So in supervised learning, a model is a complex collection of numbers. Just try and think wide. It's a complex collection of numbers that defines the what the mathematical relationship from specific inputs. What are these inputs now? Features, or you could say feature pattern to specific outputs. And what are output again? Labels. Okay, so the model discovered this pattern through training, and this training now, did I have it here? Do I have it here? Okay, I have it. And this training, a picture, it's when a student is trying to train itself by learning sorry,
Sorry, please,
did you
could you come
lost me?
again with the model definition? No, we did not lose you. Could you come again with
Okay,
the definition of model?
okay, I'll do that. Now, if a picture model, how should I take it now? Mm, okay, now let me try. You could say like in supervised learning, remember that all of these are under supervised learning. So you could say that a model is a complex collection of numbers. When they say they are training a model, what is this model? It is, how should I say, it is complex. There are a lot of them now, not data. You're done with collecting data. So now you are now using the examples inside it. Okay, inside the how should I call it? Can call it features now, but they are complex and not large. Okay, so you could say that it is a complex collections of number that defines what you could say the mathematical relationship for what specific inputs, and this inputs could be still features because they are for a way that now it could have a lot of features to help you predict like the humidity, the temperature, the cloud coverage, and all of that. So these one now they are large. Okay, so they use this specific input feature patterns, right, to get specific outputs or labels values. So what this does is that the models discover these patterns, what through training, through learning, to get this expected output. Do I have the definition there? No, but the explanation and this should help. Okay, now let's get to training. We've talked about data, we've talked about data sets, we've talked about model, we've talked about learning, training. Let's get to what's training and training itself now. Now, think of it this way, that before a supervised model can even make prediction, it must be trained first. It must have a lot of determining how should I say values to learn, to train. So before it can even make prediction, it must be trained. And to train a model, we give the model a data set, okay, with what? With label. What are labels? Don't forget they are what? They are what? Outputs.
Output.
Don't forget. They are outputs. And it must have outputs and it must have examples in futures. So the model's goals now is to work out the best solution for predicting the labels. I'll be using labels now, so we are done with output. So if I use label, know that it's either output or result. Okay, so it's for predicting the labels from what? From the features. And what are the features? Determining the values or factors. And the model finds the best solution, okay, by maybe comparing its predicted value to the label's value. Okay, so when it gets its predicted value to label's value, that is when loss come in that I talked about. Okay, so based on the differences between the predicted value and the actual value, that is where loss is. So you could take loss definition as a difference between the predicted value, remember when I talked about this, and the label value. Okay, all right, and I think I did justice to that here. Let's say that the label exact value is 0.5 and your predicted value is either 1 or 2. So it's left for you to retrain yourself to learn, okay, to train the model to it gets to this value or something very close to this value. Okay, did I have training definition? Okay, so training is the process of feeding, all right? It's a process of feeding the model with the training data. And what are these data contains of the features and label, you know what they are. So they can, so that it can learn the underlying relationship between them. And what are these relationship now? Take your mind to the loss. So the model adjusts its internal parameters during training to minimize the difference between the prediction and the actual value. What did I say is the difference now in the loss? It is called loss. So just to minimize this, it adjusts internal parameters. I don't know if you could remember I made mention of house color. House color does not have anything to do with what's the price of the house. So it would be very funny if someone asks you the price is this, it's like what's the color of the house? Is it blue? It doesn't matter if it's blue or white or pink. The price, there are some parameters that are very important. So this is what it's saying here, that the model adjusts. So there are some examples which are what features. So there are some features in your how should I say, in your training data that are not, that does not have any relationship, so you can just take them out. So this is where this adjustment comes in. So it adjusts internal parameters during training to minimize the difference between prediction and the actual value. So you could say to minimize the loss in short, because of course loss is the difference between prediction and the actual value. So there's another one called evaluation before I even get to test. Okay, let's discuss test before evaluation. So now testing now is the process of evaluating the performance of the trained model on what a separate data set called the test data. All right, so you could say this test data now could stand as let's say a case study, right? So the test data is not used during training, you get it now, and during training, and is used to assess how well the model generalize to new. Okay, so what this means is that during training, it is used to assess, it's used to check how the models also generalize to new values, unseen values that you've not even seen. Okay. So the performance of the test data is good indicator of how well the model will perform a real world application. So I just remember that I told you to call my attention to this, but I think I talk about that. I talk about model training, core process of learning from data. Now this data quality is when you can take your mind to large data or size and highly diverse data. So this is the quality of data. You could not have a very small data and it's diverse, or a very large data and it's small. So the quality comes when it supports large and very diverse. Algorithm choice, made mention of that. Which one will you use, and training process? Okay. Data, machine learning algorithms. Okay, we talked about these applications, real world problem solved by machine learning. I've been trying to relate each examples to real world, so I think we've done justice to that. Talked about this, and unsupervised learning tasks. We talked about clustering, and we talked about this reinforcements. Okay, requirement cycle, we did that. Key concepts in machine learning. Okay, so I've talked about training now. Let's talk about the last thing, evaluating. Now, we evaluate a trained model to determine how well it's learned. This model that we are using, do we need to adjust some things? How is the model? So now this evaluating is when you come to mind, how well does it learn? Okay, so when we evaluate a model, we use a labeled data set, but we in this case we could only give the model the data features, you know what features is, and we then compare the model prediction to the model's actual value. Okay, so now I've been talking, let me still test your understanding. So why does a model needs to be trained before it can make prediction? You can just tell me one word now. So why do you think we need to train a model before it can make prediction? Are we together? Do you lost me?
So you can have what to work with.
Yeah, beautiful, beautiful. All right. So before then, let me talk about we can draw inferences from it. I don't know. I did this document this evening. That is why I was late to join the class. So I missed something, but they are in my head. I'll still try and do justice to it. So after evaluating it, you can make inferences. So this emphasis comes when you are satisfied with the results from the evaluating model. Okay, so just one word, yeah. If you don't take anything, just take that once you are satisfied with the results. So inferences could come when you are satisfied with the results from what from evaluating the model. We can use the model to make predictions. Okay, later on. So what are these? We call them inferences or what on level example. So let me say take your mind to the maybe the weather app or the weather that I've been talking about example. So we could give the model the current weather condition presently, like what, like temperature, atmospheric pressure, relative humidity, and it will predict the amount of rainfall now currently. Based on that, it has learned, we train it, we test it, we evaluate it, and we now make inferences. Yeah, maybe we are satisfied with it. Okay, so I tried to make a very simple visualization here. Key concepts in machine learning. Supervised. We have the features, you know what features are, labels, I've been talking about it, training, testing, and others like evaluating and inferences. Okay, so there are a lot, but this should be another class entirely so that it will help you because we've been talking. These are the explanations of everything. These are the explanations of everything. So when we get to implement it, is say next class, we'll get to introduction of Scikit-learn. So now this Scikit-learn um is when we now apply all this we've been talking, all this we've been learning. And here for the testing, there is a method, the pattern. I just forget. So it is crucial to split the available data into training and testing sets to avoid overfitting and underfitting. Can get that. So overfitting occurs when the label learns the training data too well and performs poorly on new data. Common split is, yeah, these are the method you use to train the data. We look at it. The common method is 80-20. We call it that way. We call it 80-20, or you can use the 70-20. But a lot of people worked with this one. They use 20%. %, to train.
I'm sorry, we
Okay,
lost
so
you.
oh, beautiful. Wow, sorry. So I just forgot this part. Nothing much. You've not lost me for long. So it is crucial to split available data into training and testing. Splitting your data now into training and testing to um, training and testing to what was it? It is crucial to split the available data into training and testing sets to avoid either it being overfitted or underfitted, to avoid overfitting. Now, for the overfitting, it occurs when the model learns the training data too well and it performs poorly. Or when it's another one, underfitting is when it does not have a lot enough data to be trained and it also performs poorly. And there are common splits of that. These are common ways of testing and training data. We call it 80-20 and 70-30, where you use 20% for testing and 80% for training. And the other one, sorry, I did not add it. The 70-30 is when you use 30% of your data to test and 70% to train. Okay, so I want to stop here today because we've talked much. And then again, these are just the overview explanations. I will leave these documents with you, and I also leave it on the video description when I get it. And where we get to practice all these things that we have we've talked a lot, we've preached a lot about it, is when we get to Scikit-learn. It's a very popular Python library that helps us to work with machine learning. So all this that we've talked, we use Scikit-learn to apply it to real life. Okay, so I already made it, but I'm not done yet, and it's very large. Is when it comes to, you see, make prediction on the test data, evaluate model, make predictions on new data. It's a lot, so it is a topic
So
on
do
its
we
own.
need to do we need to download it or
I
install
was
it
saying
on
it's, you mean the Scikit-learn or these documents?
the
Okay, of course you need to install it just like other Python's library. Just to know, there are lots about it, but just to know that it works with NumPy that we've talked about. It works with Pandas that is talked about, and it's built on not on NumPys and Pandas, and it even works with CPython. Is it ShiPython or CPy, something like that? It works, so it's just like others Python library where it gets to install. And of course, you know the inputs, the command to install it, pip install. So you could pip install, use this command to install it. Or why I'm not stressing that since you're using Google Colab, all of these are pre-installed. But since you want to use your machine, maybe you could use pip install Scikit-learn. Scikit-learn. We call it Scikit-learn or science. Till we get there, let me not bother you much. But this is the documents I will upgrade it, and this will be a topic on its own. Yeah, where we get to apply this thing is after we apply this is when you work on your projects. I think, let me see, do I still have your projects with me? Yeah. This is your projects. This is yeah, machine learning. What is machine learning? Types of supervised, unsupervised. We talked about this, key features, model training. Yeah, and this should be very good. Introduction to Scikit-learning, build, and this will be your project. So after next class, you work on this project. Build a simple linear regression. We've not talked about regression, that is why we've not implemented. So build a simple linear regression model using Scikit-learn. So this is actually going to be your next project. And talking of next projects, some people submitted their projects and I'm yet to receive from some. So try and submit your project. It will help you. Yeah, why is helping you to test your learning and to build these things. Another thing I forgot last time, each project you work on, try and push them to GitHub. Those are your portfolios, please. All right, so we stop there today.